Hey there, we are looking at this problem linked list cycle. This problem is about determining if the linked list has a cycle. What does it mean? As you can see in the example, this 3 points to 2, 2 points to 0, 0 points to -4, and -4 points back to 2. This is forming a cycle, and we are supposed to find out that the cycle exists. A simple and naive approach to the problem would be, let's remember all these nodes. So let's create a map. Let's remember all these nodes. This would be 3, 2, 0, and -4. If we receive any of these nodes again, which we are in this case 2, we call it a cycle. But as you can see in the end of the problem, we are supposed to solve this problem in O1 space. In our approach, we are taking O of n space, which we are not supposed to. So how do we solve in O of 1? Now, even though this problem says easy, there is something you need to know to solve this problem. And this is a concept used many times in LeetCode problems. It's called the fast pointer and the slow pointer. So what does it say? Fast pointer is basically a pointer to any of the node and it moves fast. In linked list, we usually do node dot next. In the fast and slow pointer approach, the fast pointer says fast dot next, and the slow pointer is slow dot next. Basically, the slow pointer moves slow and the fast pointer moves fast. How this helps us is that if at any point fast and slow match, this is strange because this should not happen in a linked list without cycle. Let's take an example. If I have something like this, let's create fast and the slow pointers. The fast pointer is here, the slow pointer is here. After the first iteration, the fast pointer should be here, the slow pointer should be here. In the next iteration, the fast pointer should reach the end and the slow pointer should be over here. The fast pointer would not move anywhere after this, which means fast and slow will never become equal. But what if there was a cycle? Let's say we have a problem like this. We have a cycle going from 5 to 3 and from 3 to 4 and 4 to 5. We can visually see there is a cycle. Now let's use the fast and the slow pointer approach here. The fast pointer after the first loop will go over here. The slow would be over here. The fast would then move to 5 and the slow would move to 3. After that, the fast would move back to 3 and from 3 to 4. So the fast would be over here and the slow would move one step forward, which means here. As you can see, the fast and the slow became equal, and this can only happen if you have a cycle. So this is what the fast and the slow pointer approach is, and this is what we would use to solve this problem. Now let's take a look at the code to understand it better. So we are here in the code editor. We are given a function which takes a head. This is the head of the linked list. Let's create a fast pointer. Fast equals to head and slow equals to head, both pointing on the same node in the beginning, let's check, let's move forward in this linked list. So I would write a while. I would check if the fast dot next exists. I don't have to check slow because fast would already validate the path. So slow is only moving in a place where fast is moving. So fast would already validate the linked list path. So slow does not have to check anything in the while condition. We don't have to check if that node is valid or not, if it is none or not none. But over here, we have to check if fast is not none. Otherwise, we would have a scenario where we would do none dot next. So I need to check if fast exists. If fast exists, let's also check if fast dot next exists. In the next line, let's move fast. Fast equals to fast dot next. Slow would move slow dot next. Now we need to check if fast and slow are equal at any point. If fast is equals to slow, this cannot happen in a linear linked list and we have a cycle. Return true, which is we have a cycle. If we exhausted the while loop, which means either fast or fast.next reached the end, which means we do not have a loop. Let's return false. Let's run this code. It's passing. Let's submit it. So we have a solution.